someone needs this information that's not able to be here, and I'm going to share my screen. And mini project 6 deals with linear regression. And so remember, with linear regression, you have to have 2 quantitative variables. So for example, if you're using the US president's data set, you could look at, is there a relationship or is there a correlation between weight and cholesterol level? Or is there a relationship between weight and height? Is there a connection between, say, age and cholesterol level? I think that's on that data set. So you've got a few options, but remember, you have to choose 2 quantitative variables, meaning you got to choose 2 variables that involve numbers. Jeannie, for you, with the education data set,
that one's hard.
yeah, I'm trying to remember what's in that data set.
There are raw counts, so you could do something with counts.
Yeah. I would say sort by grade level, but that's going to give you more than 2 categories. So I was trying to remember. Let's see if I can pull that one in. I think it's a worksheet. I can't remember right off what's on that. Oh, that's an Excel spreadsheet. It may not pull it in. Maybe it will. But I'm trying to think. It gives you the count, but does it also give you their... Let's see what we've got. Okay, this is the full data set. So
maybe something with the number tested.
Yeah, you could look, well, I'm wondering if you could look at like the number tested, and maybe you could do like the number that were proficient. And see, I mean, which there should be a relationship there without a doubt.
Right, yeah. The more tested, the more.
Yeah. I'll try to look at it a little bit more, but you need 2 quantitative. So maybe the number tested and, you know, something about proficient or distinguished. I'll try. I'm sure I had a suggestion, but I don't remember what it is off the top of my head. But do you have questions maybe lingering from linear regression? Did you understand the process? I think you took that quiz on Sunday. So do you have lingering questions that I might need to clear up before we get into the next lesson that will help you do this project? Jeannie, I'll look again because I know I had something from the last time we used that data set, but I just don't remember what it is. Okay, if a question comes up, we do have class on Thursday. You're welcome to ask then, or you can always drop me an email. We are in module 4. Okay, and the topic of discussion for really this week, it's scheduled to be today and on Wednesday, are 1 and 2 proportion test. But I'm hopeful that this particular lesson won't be that difficult for you because it is very similar to the 1 mean and the 2 mean test that we talked about back in module 3. So I did post in the course yesterday around lunchtime. I posted an updated PowerPoint for one proportion test, an updated PowerPoint for two proportion test, and then also a Word document that has the examples for both one proportion z-test and two proportion z-test. They're on the same document. So that's there in D2L. So I'm going to go over to the PowerPoint for the one proportion z-test and kind of talk about it, and then we'll get into actually how to do it. So the one proportion z-test is really the same process and procedure as we had with the one mean z-test that we discussed in Module 3. Remember that a hypothesis or hypothesis testing is related to a population parameter. It's related to some numerical measurement connected to the population. In Module 3, the focus or that parameter was the mean or the average. In this lesson, in Module 4, the focus is going to shift to a proportion or a percentage. Sometimes it's presented as a percentage, but the process is still the same. We still have to state the hypotheses, identify the information we need, calculate the test statistic and its p-value, make a decision, and write a conclusion. So the process of hypothesis testing isn't changing. Again, we're shifting our focus from that population mean or average to a population proportion or a population percentage. There are some specific guidelines about when you can use a one proportion z-test. I want to make you aware of those because if you were doing this, with your own data, with real research that you were doing, you would have to make sure that these guidelines are met. For our purposes, we're going to assume the guidelines are met, but here are the guidelines. You still have to ensure that you're using a simple random sample. Again, a simple random sample means that every item in the population had the opportunity to be selected, that one was not favored over the other. The population is at least 20 times as large as the sample. So if the population, let's say we had a sample of 100, that means that our population would need to be at least 2,000. And that's to ensure that you get that simple random sample and you don't have to worry about oversampling one particular thing. The individuals or the items in the population are divided into two groups. You could have male, female. It could be smokers, non-smokers. It might be, I don't know, it might be that you have, say, over the age of 20, under the age of 20. Okay, so you have to have them divided into two groups, which is similar to the idea of a binomial distribution. Okay, and then the values of n times p sub 0, which would actually be the average. It goes again, it connects back to a binomial distribution. N is your sample size, P is your probability of success, that you get what you want, and then N times Q, the sample size times the probability that you don't get what you want, are both at least 10. Again, and that's just some conditions that kind of ensure that things work the way we need them to. But again, for our purposes, we're going to assume that those conditions are met. I will also tell you that in this particular topic, we're only going to look at it from a summarized data perspective. You know, if you go back and think about the others, we've looked at it where we had summarized data, but we also had examples where we had the raw data. For the one proportion z-test, we're going to be only using summarized data. It can be done with raw data, but the process is a little bit more involved, and so we're trying to keep it fairly simple in this course. So the notation for a one proportion z-test changes slightly because we don't have the sample mean and the standard deviation and all that kind of stuff. So I wanted to introduce you to the notation. They use a lowercase p to represent the probability of success, which is the proportion or the percentage that the event occurs or that you get what you want. So if I'm trying to look at, say, the probability that someone's a smoker, then my P would be the probability that they smoke, and I get what I want. It's not necessarily a good thing, okay? It's just that you're getting what you want. And you have to be careful here, guys, because this lowercase p is not in any shape, form, or fashion the same as the p-value. Okay, and I've been trying to be very deliberate and still call the p-value and not just say p, because I knew this was coming. Okay, so a lowercase p represents the probability of success. And again, this is a little bit of a carryover from the binomial distribution that we talked about earlier in the semester. P in the context of a one proportion z-test is equivalent to the idea of our population mean. It is typically going to be written in decimal form and is usually stated in the scenario. It's usually given in the scenario, much like the population mean was given in the scenarios for the one mean z-test. Now, if you are not given the probability of success, if you're not given that P, then we will assume that it's 50%. And we assume it's 50% because remember, we're going to have two categories. Yes, no. 5, not 5. Smoker, not smoker. So you have two categories. So there's a 1 in 2 chance that you're going to get that thing, or 50%. So if it's not stated, we do use 50%. Q, we use the letter Q to represent the opposite of that, which is the probability of failure, or that's the proportion or percentage the event does not occur and you do not get what you want. P plus Q together, because they're probabilities, have to total to 1. So if you manipulate that a little bit, we know that the value for Q is 1 whole minus P, the probability of success, because typically Q is not given in the problem, so you may have to calculate it yourself. But to calculate it, you simply subtract the given p-value from 1. Again, Q is usually written in decimal form. N represents the sample size or the number of events. I believe Minitab refers to it as the number of events. So let me make a note right there. Okay, N, the sample size, I believe Minitab calls this the number of events. How many times did you?
Laura?
Yes.
I'm not, it might just be me, but I'm not seeing,
Oh.
is it you seeing the PowerPoint?
Oh, I'm sorry. Did I forget
It's
to
okay.
share the screen? I'm
I actually
sorry.
pulled it up too, but I didn't, like, it looked like you were writing something.
Okay.
So
Okay. I'm sorry.
no worries.
Okay, so let me go back here for just a minute then, since Miss Ralston made a boo-boo. Okay, but again, the one proportion z-test is pretty much the same as the one mean z-test. We focus on the population proportion rather than the percentage, and our guidelines are listed there. But again, for our purposes, we're assuming that those guidelines or those conditions are met. And then this is the symbols. You have a lowercase p, which is your proportion or percentage that the event occurs. You get what you want. But again, be careful, because that does not in any shape, form, or fashion represent the p-value. Okay, I've been deliberate about calling the p-value p-value. Q is the probability of failure. Okay, and P plus Q, again, they're probabilities. So we know that P plus Q have to total to 1 or 100%, because remember, 100% means something's going to happen. N is the sample size, or again, Minitab, I think, refers to that as the number of events. How many times are you going to do that particular experiment? In the context, and let me blow this back up again if I can, where I can. But the mean of the population, again, I made the statement up here that P is equivalent to the population mean. So the mean of the population is P. And if we need it, we can calculate the standard deviation. And I'm going to write it over here to the side because it's covered up. The standard deviation is P times Q divided by N. And again, that's kind of a carryover from the binomial distribution. The formulas are slightly different, but again, it's very similar to the idea of the binomial distribution. In terms of the different scenarios that you can have, you have pretty much the same options that we did for the one mean z-test or even the one mean t-test. You can have a one tail left tail test where your proportion is greater than or equal to a particular number, and the alternative would be less than. The null could be that the proportion is less than or equal to a specific number, and the alternative would be greater than. Okay, it's the same pairings that we've had before. The null will still always and forever contain equal in some form. So you can also pair it for a two-tailed test where the null is that the proportion equals a specific number, and the alternative would be that it does not equal a specific number. Again, that specific number, if I go back to this first slide that I didn't have up on the screen, or the second slide, typically those values are written in decimal form, and they are typically, the p-value at least is given in the problem. If it's not, we use 50% as the default. But again, the process is virtually the same that we've had for all hypothesis testing, and we're going to walk through that in just a minute. On slide 5, I have the steps that you need in Minitab to get to the answers. And I apologize, I got this wrong. The sample size is the number of trials, not the number of events. Sorry. I was going off of memory. Trials. Okay, so the instructions for Minitab, which we'll walk through together in just a minute, are on slide 5. Slide 6 is our first example. So I'm going over to the Word document that again is available in D2L so we can walk through it together. And the first example says, according to CBS News report, I got a typo. According to a CBS News report, New York City's adult smoking rate was 12% in 2022. Suppose that a survey is conducted to determine this year's rate. 9 out of 70 randomly chosen New York City residents reply that they smoke. Conduct a hypothesis test to determine if the rate is still 12% or if it has decreased. Use a 0.05 level of significance. Now, we've talked a couple of times about being able to identify the fact that this is a one proportion z-test. The biggest clue that this is going to be a one proportion z-test is that you have percentages given. Okay, so, and I only have one percentage. So I recognize it as a one proportion because I'm given information in terms of percentages. Okay, again, nowhere in this paragraph does it talk about the mean. So there's no mention of a mean. I will say that if you're doing a proportion test, whether it's a one proportion or a two proportion, it's always going to be a z. There is not such a thing as a one proportion t test. It's only z. Okay, so again, that's the clue that you would likely be doing a one proportion z-test, is that your information is given in terms of percentages. There's no mention of a mean, and I only have one percentage. So that kind of again lets me know that I'm doing one percentage or one proportion. So the first step in any hypothesis test is to state the hypotheses. So we have the null and we have the alternative. So if I look at this problem, it says determine if the rate is still 12% or if it has decreased. Now that wording is kind of different from anything we've ever seen before. What do you think the phrase is still would imply mathematically?
Equals.
That it's equal, or it has decreased, which would mean it's lower. So I'm really saying it's less than or equal. Okay, so be real careful, watch those words. Because it has both, this is the null because it contains the equal. So we're saying that our proportion, which we represent with a P, is less than or equal to 12%. And again, we change the 12% to a decimal. If you don't remember to change any percentage to a decimal, we divide by 100. So if the proportion or the rate is still or has decreased from 12% is the null, the alternative then would be the exact opposite, which is that it's greater than. For step 2, Step 2 in the process is to identify the players. Okay. And so I haven't given you a formal list here, so let me give you the list. You're going to need P, which is your population proportion, and it's going to come from the hypothesis. You have X, which is the number, we need to have calls it the number of events. This is what, when you get what you want, how many times do you get what you're interested in? Okay, and that should be given in the problem. N is the sample size, or the number of trials is what Minitab calls it. And again, that should be given in the problem. And then you also need, as always, your level of significance. And connected to that level of significance is the confidence level. Because Minitab asks for the confidence level. We've kind of learned that as we've been working through these. So again, all of the information that you need to work the problem has been given. Okay, and those are the 5 things that you need. You need the population proportion, which for us in this problem is 12%, again written as a decimal. If I go back to the story, in the 3rd sentence, it says 9 out of 70 randomly selected residents reply that they smoke. So 9 people said that they smoke out of the 70 that we surveyed. And it says use a 0.05 level of significance, which means my confidence level is 95%. Remember, your level of significance and your confidence level have to total to 1 or 100%. Step 3 is to calculate the test statistic, which in this case is going to be a Z, and its p-value. And we're going to do that using Minitab. So I'm going over to Minitab. I'm going to get a new sheet. We go to Stat, Basic Statistics, 1 proportion. Again, we are dealing with summarized data. The number of events in my survey, we had 9 people indicate that they smoke out of the 70 that were surveyed. I am performing a hypothesis test, and my hypothesized proportion is 12%. Options. We're doing a 95% confidence level. We're saying that the proportion is greater. Make sure you choose the symbol in the alternative hypothesis. and we use the normal approximation method. Okay, so you choose your confidence level, the symbol that's in the alternative hypothesis, which for us in this problem is greater than, and we're using the normal approximation method. I click OK. Click OK. And under the test, Minitab gives me my z-test statistic and the p-value. And I will need to write those down. So my z-test statistic is 0.22. My p-value is 0.413. Step 4 is to make a decision. And we're going to make a decision by comparing the p-value to the level of significance. Just like we've been doing, that process hasn't changed. The p-value comes from Minitab, which is 0.413. The level of significance is 0.05. We compare digit for digit. So 4, first number after the decimal, compared to 0, first number after the decimal. 4 is greater than 0, so the p-value is greater than the level of significance. When p is greater than the level of significance, we fail to reject the null. Okay, then step 5, again, which hasn't changed, is we're going to write the conclusion. Now I'm going to go back up here to my problem and think about what this means. If I fail to reject the null, I fail to reject the null. That means the null is true and the alternative is false. So my conclusion is written in terms of the true hypothesis. And so it actually does show we were trying to determine if the rate is still 12% or if it has decreased. Based on the data that we have collected, that's what we've proven. We've proven the rate is still 12% or it has decreased. So I want to state that in my conclusion. So I would write at the 0.05 level of significance. The New York City adult smoking rate is still 12% or has decreased. Now, hopefully, that doesn't seem like a completely new concept to you, okay? It's the same process, but we're doing it with a proportion or a percentage. Questions before we move on? Okay, let's look at the second one then. A global poll was also conducted by Gallup, and it uncovered that out of the world's 1 billion full-time workers, only 15% of people are engaged at work, leaving a significant 85% unhappy at their jobs. A local flooring manufacturer believes that less than 85% of the company's employees are unhappy at their jobs. A survey of the company's 22,000 worldwide employees is conducted, and 5,200 report being unhappy at their jobs. Use the 0.10 level of significance. What conclusion can be made about the company's employees? Okay, so again, as I'm reading through this problem, I notice that I am given percentages. There's no mention of the mean. So that's my clue that I'm going to do a 1 proportion z-test. It's 1 proportion because I only have information about one thing or one sample. So we begin the process. Step 1 is to state the hypotheses. Okay, and this one is maybe the hypothesis may be a little bit hidden. It might be a little bit more challenging to recognize it. But again, remember, you want to look for words like claim, believe, think. And so if I look in about this third sentence, it says believes that less than 85% of the company's employees are unhappy at their jobs. So the belief is that for this local flooring manufacturer, the rate of unhappy customers is less than 85%. So I see that phrase less than, which I hope makes you think of the less than symbol, which does not contain equal. So this statement highlighted in green is going to be your alternative. I know some of you have got that down pat, but I also know that some of you are still struggling identifying your hypothesis. So we would have that the proportion is less than the 85% as the alternative. Again, that's the one that's given. My null, therefore, would be the exact opposite, which would be greater than or equal to the 85%. Step 2 is to identify the players. Okay, so we have H sub O and H sub A. Oh, good grief. I'm sorry. Okay, so for our players, we need the population proportion, the number of events, how many said, yeah, I'm unhappy with my job, the number of trials or the sample size, significance level, and the corresponding confidence level. So I know that P comes from the hypothesis, which is 85%. If I go back and read the problem, it says a survey of the company's 22,000 worldwide employees. So that appears to be the total. 5,200 reporting being unhappy. Okay, so we have 5,200 reported as being unhappy out of 22,000. And it says use a 0.10 level of significance, which means we have a 90% confidence level. Remember, confidence level and significance level have to add to 100% or 1. So then we're at step 3. At step 3, we're going to calculate the test statistic, which again is going to be a Z, and its p-value. Out to Minitab we go. Stat, basic statistics, 1 proportion. The number of events, there were 5,200 who claimed they didn't like their job out of 22,000. My hypothesized mean is 85% or 0.85. My confidence level is at 90%. My alternative hypothesis is less than, and we do use a normal approximation. Click OK. Click OK again. And again, under test, I get oops. See if it'll let me move that over here. Okay, so for my test, I get a Z value of negative 254.90, and the p-value is 0. Then, as always, step 4, we're going to make a decision. We always make a decision by comparing the p-value to the level of significance. The p-value always comes from Minitab, which in this case is 0. The level of significance comes from the problem, it's given. We compare p-value to level of significance, digit for digit. 0 is less than 1, so p is less than or equal to the level of significance. When p is less than or equal to the level of significance, we reject the null. So again, thinking about that in this context, if we reject the null, that means the null is false and the alternative is true. So based on the evidence that we collected, it does appear that less than 85% of the company's employees are unhappy at their jobs. So I would then, in the last step, write my conclusion. Primary thing to remember about your conclusion, and I probably sound like a broken record because we've been doing this for so long, is you want to include the level of significance. So at the 0.10 level of significance, we could literally say less than 85% of the local flooring company's employees are unhappy in their jobs. Okay, questions? Again, I hope it doesn't look like something totally brand new off the wall. It should seem similar to something that we've done before. Okay, let's go over then and begin the conversation of a two-proportion z-test. Again, a two-proportion z-test is going to be the same process and the same procedure that we had for the two-mean z-test. Again, you're going to state your hypotheses, identify that necessary information, calculate your test statistic and p-value, make a decision, and write a conclusion. It's the same process. The difference here is you're going to have two samples instead of just one. And we're shifting our focus again from the population mean to the population proportion or the population percentage. And again, that's going to be your clue that you're going to do a two-proportion z-test. One is you're going to have percentages. Two is you're going to have two. You're going to have two different samples. There are some guidelines very similar to the ones we had before. And again, for our purposes, we will assume that the conditions are met. But if you were doing, if you were doing this in the real world with real live data that you had collected yourself, you would want to initially determine that these guidelines were met. Again, we still want to make sure that we use a simple random sample where every item in the sample had the same opportunity of being selected, but we also want to make sure that those are independent, that the outcome of the first sample, is not affected by the outcome of the second, or even within the sample, the outcome of the first draw is not affected by the second draw. So this is more like even like the two-mean t-test when you had independent samples. The number of successes, again, the probability that you get what you want, the number of getting what you want, should be at least 5. And the number that you don't get what you want, the number of failures should also be at least 5 for each of the samples. Literature, sometimes things change over time or as further research is done. So growing research states that the population, gosh, I got the yawns, I'm sorry guys, must be at least 10 or 20 times the size of the sample. So again, if you're using a sample, say, of 100, that means that your population should at least be 1,000 to 2,000. Again, that prevents oversampling and causing incorrect results within your test. Again, for our purposes, we're going to assume the conditions are met in the scenarios that we're given. The notation, I didn't add a slide here about notation, but this notation really doesn't change, but you have to be careful because you're going to have information about sample number 1, as well as information about sample number 2. And you'll have to keep those straight. And it does matter, we saw that earlier, it does matter which one you make sample 1 and which one you make sample 2, and we'll talk about some of the phrasing in the questions that may help us decide that. Again, you have the same options that we had for the two-mean z-test. You can indicate that the two proportions are greater than or equal to each other, and then the corresponding one would be that they're less than. You could have the null hypothesis that one proportion is less than or equal to the other. And then your alternative would be that they are greater than. And then for the two-tailed test, we would say the two proportions are equal or they're not equal. Okay, so it's the same, again, the same 3 basic scenarios that we've had, throughout hypothesis testing. I've given the Minitab instructions on, I believe it's slide 4. Let me make sure. Yep, slide 4. Again, it's pretty much the same idea as before. We are going to only be dealing with summarized data, but you will have information for 2 different samples. Okay, so let's see if we can take a look at least one example. Whoops, I didn't mean to stop sharing. At least one example before we end today. We may not be able to do more than one. So let me get out of this one, maybe. And go back over here. Okay, so the third question on our document, and I'm going to make some space here, says, a survey found that 83 out of 100 men questioned preferred computer-aided instruction to lecture, while 75 out of 100 women preferred computer-aided instruction to lecture. At the 0.05 level of significance, test the claim that there is no difference in the proportion of men, which indicates it's sample 1, and the proportion of women in sample 2 who favor computer-aided instruction over lecture. So one of the things, if you'll notice, one of the conditions we had earlier for a 2 proportion test was that you had to have 2 groups or have it divided into 2 categories. So in this case, our 2 groups or our 2 samples, we're looking at men and women. Within each sample, we're looking to see whether they prefer computer-aided instruction, sort of like an online class, versus lecture, which would be face-to-face. Okay, so you kind of got dual doubles there, so to speak, because you've got 2 groups, men and women, but within each group you have 2 categories. Okay, because they either prefer computer-aided instruction or they prefer lecture. But one of the clues, again, the first decision that you might have to make if you were looking at this particular question, say on the final exam, is going to be, should I do a 1 mean Z? Should I do a 1 mean T? Should I do analysis of variance? Should I do 2 mean T? Should I do a paired t-test? Should I do a 2 proportion z-test? Well, it may not be as obvious, okay, but it does say in this problem, in the proportion, okay, so that's kind of a clue there that I'm going to do a test related to proportion. Again, in this scenario, there's no mention of the mean. Okay, but it does again have that word proportion in there. And I know that I need to do a 2 proportion Z because I have information on 2 distinct groups. And in this case, my 2 distinct groups are male and female. So I get the idea that it's proportion because it actually has the word proportion in it, as opposed to having a percentage. And it gives me information about 2 categories or 2 groups. So I need to do a 2 proportion Z test. We begin as we always do. We state the hypotheses. Now here again, identifying a hypothesis in this particular scenario might be just a wee bit challenging. But again, it says test the claim, so that's a good clue. There is no difference in the proportion of men and the proportion of women who favor computer-aided instruction over lecture. So again, this statement is saying there is no difference. No difference would imply that they are the equal or the same, which means this statement that I've highlighted in green is my null. So no difference means the proportion for men is equal to the proportion for women. And I listed it in that order because it told me in the problem that men is sample 1 and women are sample 2. Okay, so we always do 1 to 2. If the null is that there is no difference, the alternative would be that there is a difference or they're not equal. And I'm using the subscript M for men and W for women. You could use 1 and 2, whichever you feel more comfortable with. Question 2. We identify the players, and it almost helps you to kind of set up a table because you need X, okay, which is the number of events. How many times do you get what you want? N is the number of trials or the sample size. And we do have to divide that into the 2 categories. We have one column representing the men and a second column representing the women. And I can use the information that's given to me in the beginning of the story to fill in that table. It tells me in the first sentence, 83 out of 100 men preferred computer-aided instruction. Okay, so 83, whoops, sorry about that. 83 out of 100 men preferred computer-aided instruction, and 75 out of 100 women. Now, in this case, you had the same size sample for men and women, because realize that it doesn't have to be the same size group. I could use 100 men and 150 women. Okay, the calculations that go on behind the scene for the 1 proportion Z does take into consideration the size of the group. We do also still need our level of significance, which in the problem, it tells us that the level of significance is 0.05. Which means the confidence level is 95%. Step 3 in the process is to calculate your test statistic. And we're going to use Minitab to do that. Okay, so we're going to calculate the test statistic, which again is a Z, and its p-value. Using Minitab. So I'm going out to Minitab. We do stat, basic statistics, 2 proportions this time. Again, we have summarized data, For sample 1, which was the men, 83 out of 100 indicated that they preferred computer-aided instruction over over lecture. Was it 75? Well, come on. 75 out of 100 women preferred computer-aided instruction over lecture. Then we go to options. We're doing a 95% confidence level. Our hypothesized difference will always be 0. We are looking at, is there a difference? So we would do not equals. And we want it to estimate the proportions separately. Estimate the proportions separately. I click OK. I click OK again. And again, Minitab gives us a bunch of different information. What we need is the test information. Whoops. Now, notice here, it gives you the Z value and the P value for the normal approximation, which is the method that I told it I wanted to use. It also gives me a value called Fisher's exact. That's where it's figured it exactly, and it's a different P value. It's the same test statistic for Z, but you get a different P value. Okay, so make sure you read the one for normal approximation. We're going to write it down. So my Z is 1.40. The P value via the normal approximation is 0.163. Then we're going to make a decision. Same old, same old. We make a decision by comparing the p-value to the level of significance. Okay. So our p-value, which comes from Minitab, is 0.163. My level of significance is 0.05. Again, you're going to compare those digit for digit. 1 compared to 0. 1 is greater than 0. P is greater than the level of significance. When the p-value is greater than the level of significance, we fail to reject the null. Well, what does that mean in the context of this problem? If we fail to reject the null, that means the null is true and the alternative is false. So we were trying to prove that there's no difference in the proportion of men and the proportion of women who favor computer-aided instruction. And basically we've proven that. We've proven that the proportion for men is equal to the proportion for women. They're not different enough for us to conclude something weird is going on. So we would write out our conclusion, which is the 5th step. It's always the 5th step. All right, so we would have, and I'm almost there, got 2 minutes, at the 0.05 level of significance, there is, whoops, no difference in the proportion, I could say proportions of men and women who prefer computer aided instruction. Okay, that's one example, but again, hopefully it's not something that is totally brand new to you. It's the same process. You're just applying it to a proportion or a percentage rather than to a mean. But do you have, I got about a minute to go. So do you have questions before we end today?
I've got a quick question, but it's very related to my data, so it might not interest Naomi. So.
Okay, so hold on a second and let me, I'll